Okay, in our last episode, we were looking at this thing here. And what was it? Well, it was a way to represent a pointer to a function. It doesn't point, it has nothing to do with the insides. It's basically a reference to the beginning of some function. In this case, our hello world function. We're going to trim this up a little bit. And right here, when I say, I was playing a little bit beforehand, fun is a pointer to a function that fits a particular pattern. What is that pattern? The function begins with void, passes one parameter, and the variable name is fun. In this case, I'm going to say fun is equal to the address of hello. So now when I say fun parenthesis to close parenthesis, the compiler says I know what fun is. Fun is anything that matches, any function that matches this pattern. The address hello does match the pattern. The compiler will generate code so that the number 2 is passed as an integer onto the stack here. And then the system will jump in to this hello function. Let's confirm that it works. Hello, hello, and then hello, hello, hello 3 times. It works. What else can we do? We can have a little bit more fun by saying typedef here. So now it's no longer a variable, it's actually a data type. So the compiler is complaining because that's like saying integer equals hello. This is a data type. So what I can say is fun A. I have a variable A that equals hello. What is hello? Hello is the address of this function. What is A? A is a variable that points to a function that matches this pattern right here. So now I can say A is basically it's an alias for this function hello. Compile and run. And there it is, 2 and 3. What else could I do? I could have an array for fun, say a list of, I can put 3 functions in here, but I'll just put hello, hello, hello for now. And what is this? It's not a list of 3 integers, but it's a list of 3 fun things, functions that fit this pattern. So now we'll have a little bit more fun. I'll say for, and I'll say integer I, oh, not integer, I'll do auto, I'll do integer. Integer I from 0, 1, 2. And I'll say hello. I'll say list I. And what is list I? List I is going to be one of these items. But what is that item? I don't know which one I'm talking about. Maybe it's list 0. That would be this one. But what is it? It is a function. So I can pass it a parameter. So what this will do is it'll call this item and give it the number 3. It'll call the next hello, give it the number 3. Let's run it and see. It should be 9. 1, 2, 3, 1, 2, 3, 1, 2, 3. There it is. Groups of 3. 1, 2, 3, 1, 2, 3, 1, 2, 3. It worked. Now they all don't have to be hello. I can pretend this is a robot. And I could have maybe other functions. And it could be to move some number of steps. So I could say step. And this thing I'll assume is moving steps. So this is just a, if I could spell end line. So now it'll say hello, move 3 steps and say hello. Sometimes I'm not sure why my machine does that. There it is. It's like it's doing something, but I don't know what. So now you see, the first time at 0, it finds the word hello, the address hello, gives it to number 3, and it says hello, hello, hello. When I is equal to 1, it comes over here to the address move, which is this function. So list 1 is move. Move what? 3 steps. Step, step, step. And then it goes back to hello. So here I have a list of functions. And we can do more sophisticated things. This could be rules. That is, maybe I could have a structure, a condition actions structure. And in the condition action, I say the name of my, whoops, we need this up at the top. Anywhere up here would be, anywhere above it's fine. So fun would be, I could test a condition. And I get another function called action. So instead of being a list of just fun things, this could be an array of condition action. I could spell condition and action. Now each one of these is wrong. I'll just put 2 in here. So I could have run the hello function and maybe then run the move function, comma. The next thing I want to do is run the hello function again and run the move function a second time. So now I have an array of here is my condition and there is my move. Now what I might like to do for a condition is call that fun1, call this fun C for condition, and fun A for action. So I'll make this action. You'll see what I'll do for a second for condition. And bool for a condition. So now what happened is I can run this function. If the function returns true, I can then execute this thing here. So now I could have another function, void run, and in run you give me a pointer to a list of, to a program. We'll call it P for program. I'll just write the word program. When you give me this program, this thing here would be your program, and we don't know how big it is, so comma, integer n. I know how large the program is if I don't throw it inside a vector. So instead of having some loop over here, get that out. And over here, I don't know what you want me to run. It could be, and now picture this is a computer program. Picture I have a whole bunch of these things here. It might return false. I'm just going to return true. Make life easy. So I could simply say for. I'll make life easy. Integer I starts at 0. I less than n. I plus plus, go to the last action. And I'll ask if. If what? Well, go to my program. Go to item I dot condition. Now we want some number there, I'll give it 2. If the condition is true, then I'm going to execute an action. I think my action did take a parameter. I'll use I for the parameter. So now I have a small function that says, you give me a computer program based on these idea of an action, a condition that I'll check and do, and if that condition is true, I'll run this little program. Such a funny term. So I'll say list, comma, 2. So what it is, I'm looking at run this list of 2 commands. And if I build and run, again, I don't know why my machine does this sometimes. There it is, hello, hello, because it returns true, always returns true, hello, hello, and it did step 1. Here it's step 0. So here we have a very tiny model of using functions as pointers. Now, this is still pretty messy, so we'd like to clean this up a little bit with more modern C++ using functional, and learn about functors as well. But that'll be in another episode or part.